Autophagy plays an indispensable role in maintaining brain health, and its decline is increasingly recognized as a key factor in the development of neurodegenerative diseases such as Alzheimer's and Parkinson's. In the brain, autophagy serves as the primary mechanism for clearing out misfolded proteins, damaged mitochondria, and other toxic cellular debris that accumulate with age and metabolic stress. When this essential cellular housekeeping process falters, neurons, especially those with high metabolic demands, become vulnerable to oxidative stress, energy deficiency, and inflammatory cascades that can set the stage for progressive cognitive decline. Alzheimer's disease is strongly associated with the buildup of beta-amyloid plaques and tau tangles, abnormal protein aggregates that interfere with synaptic function and neuronal survival. Under normal circumstances, autophagy identifies and engulfs these aberrant proteins, routing them to lysosomes for breakdown and removal. But in aging brains, or those experiencing metabolic dysfunction, the autophagic machinery can become impaired or overwhelmed. A similar breakdown occurs in Parkinson's disease, where dysfunctional autophagy contributes to the accumulation of alpha-synuclein and defective mitochondria, leading to the loss of dopamine-producing neurons. Restoring autophagic flux in the brain, reestablishing the balance between formation, progression, and resolution of autophagic vesicles, is now seen as a promising therapeutic direction for slowing or even preventing these conditions. Encouragingly, several nutrients and bioactive compounds support the autophagic processes that underlie cognitive protection. DHA, docosahexaenoic acid, the omega-3 fatty acid most abundant in the brain, plays a structural and signaling role in neuronal membranes. Beyond its well-established anti-inflammatory properties, DHA has been shown to activate autophagy-related genes and improve mitochondrial function, both of which contribute to better synaptic plasticity and neuroprotection. Animal studies suggest that DHA supplementation can reduce amyloid pathology and improve memory by enhancing autophagic clearance of toxic protein aggregates. Curcumin, the golden polyphenol derived from turmeric, is another potent modulator of brain autophagy. It exerts its effects primarily by inhibiting the PI3K/ACT/mTOR signaling pathway, a master regulator that suppresses autophagy when overactive. By lifting this inhibition, curcumin helps to reactivate the brain's own internal recycling system. Moreover, curcumin crosses the blood-brain barrier and acts as an antioxidant, chelator, and anti-inflammatory agent, multifaceted roles that further complement its neuroprotective actions. Magnesium L-threonate, a unique form of magnesium that can effectively penetrate the central nervous system, offers a third line of nutritional support. It enhances synaptic density and plasticity, particularly in the hippocampus, a brain region critical for learning and memory. At the same time, magnesium is essential for ADP production and EMPK activation, both necessary for the energy-dependent process of autophagy. By restoring magnesium levels in the brain, L-threonate supplementation may improve cognitive function while supporting the autophagic machinery at a cellular level. Collectively, these nutrients work synergistically to counteract some of the major drivers of cognitive aging: mitochondrial dysfunction, inflammation, and proteopathy. By gently nudging the brain's intrinsic cleanup systems, they help preserve neuronal integrity and plasticity, two cornerstones of lifelong cognitive performance. Importantly, the activation of autophagy in the brain must be finely balanced. Excessive or chronic stimulation could potentially be harmful. The goal, therefore, is not maximal activation, but rhythmic, responsive autophagy that aligns with circadian cycles, metabolic cues, and the brain's natural patterns of rest and activity. In this context, lifestyle interventions such as regular physical exercise, high-quality sleep, and intermittent fasting complement the actions of DHA, curcumin, and magnesium L-threonate. These habits provide the energetic and hormonal environments in which neuronal autophagy can proceed efficiently and beneficially. Together, they represent a comprehensive, accessible strategy for maintaining brain health through the decades, one that is grounded in the elegant biology of cellular renewal and the promise of aging well from the inside out.